In this example, we need to solve and write the solution in interval notation of this problem right here. What type of problem is it? As you can see, there is one inequality symbol here and another one here. So it's a compound inequality. And what's the highest exponent on any variable? It's a 1. So it's a linear compound inequality. There are several different ways of solving these. I'm going to choose the most efficient that I've detailed here, that says to solve a compound inequality of this form, you must isolate the variable in the middle by performing operations to all three parts of the inequality. So for this method to work, your inequality needs to be set up with the numbers going from least to greatest. And is -11 smaller than -7? Yes. And my inequalities all have to be less thans or equal to. Is that true? Yes. So I can solve this problem by this method. So I need to get my x all by itself. So the first thing I'm going to do is add 15. And I have to add 15 to the left, the middle, and the right. So all three parts have to be treated the same. When you add and subtract numbers to an inequality, it doesn't change the inequality symbols. So -11 plus 15 is +4, is less than or equal to 4x divided by 5. -15 plus 15 adds to 0 is less than -7 plus 15 is +8. Now let's get rid of the fractions. I'm just going to do that by multiplying by the LCD, which is just my only denominator of 5. So I'm going to multiply the left-hand side, the middle, and the right-hand side by 5. And so I get 5 times 4 is 20, is less than or equal to, my 5's reduce, and I get 4x is less than 8 times 5 is 40. And now to get x by itself, all I have to do is divide all three parts by 4. But I'm dividing by a positive number. Is that going to change the inequality symbols? No. That only happens when you divide or multiply by a negative number. So 20 divided by 4 is 5, is less than or equal to, these 4's reduce, so I get x by itself in the middle, which I want, is less than 40 divided by 4 is 10. So I have solved my inequality. And now all I have to do is write it in interval notation. And to do that, it helps to graph it. The numbers I'm interested in are 5 and 10. When you have a compound inequality that goes from least to greatest with less than or equal to, all it's saying is x lies in between those two numbers. So I know my x value has to lie somewhere in between 5 and 10. Can it equal 5? Yes, there's an equals here. So I have to use a square bracket on the 5 since 5 is included, but 10 is not, since as I have no equals on the less than there. So I use a parentheses on the 10 since 10 is not included. So my interval notation starts here at 5 with a square bracket, comma, 10, parentheses. And there is the interval notation for the solution to this inequality.